Welcome to the Communication Error Troubleshooting video. In this video, we learn step-by-step process to identify and solve the error. So, what is communication error? As the name suggests, it's a communication error between the indoor and the outdoor unit. Note that this error occurs only in an inverter AC system and not in fixed-speed compressor AC. When this error occurs, depending on the system model, indoor unit shows E1, E6, 36, E5, F6, F8 error code on the IDU display. Let's have a look at the different tools required to resolve the error. You need screwdriver kit, calibrated clamp meter, earth line detector, and BLDC kit. Before we start with the troubleshooting process, let's understand the reasons behind the system showing communication error. Improper earthing to unit is the very first reason of communication error. In case of unit mismatch, it shows communication error. Voltage or wiring issue is another reason behind communication error. Apart from these reasons, failure of some components also leads to a communication error. The components are ODU drive and IDU PCB, DC reactor, fan motor, and compressor. Let's start by checking the input supply to the unit. Switch off the unit and take out the power plug from the power socket. Now, plug the earth line detector in the power plug and switch on the supply. In case of any issue with the input supply, like earthing is not proper, neutral is faulty, line neutral got reversed, etc., then ask the customer to get it rectified. Now, let's check if there is any unit mismatch issue. All Blue Star machines consist of B or M drive. Now you must be thinking, what is a drive? A drive is nothing but ODU PCB. Check the unit's model number is printed on IDU and ODU. If it doesn't match, then the system will display a communication error. In such a scenario, inform your superior about the unit mismatch issue with its model number details. If communication error is not because of unit mismatch, then dig more into components failure issue. To do that, first open ODU cover and locate the LED on PCB. This LED gives us direction to further diagnosis. Quick tip: in an inverter unit, most of the troubleshooting happens at the ODU. Appropriate precautionary measures should be taken at the time of installation to ensure there is free space to access the ODU easily for any troubleshooting to be done at the ODU. Errors are further classified based on the LED at the ODU drive being on or off. If the LED is on, then we need to check communication voltage. And if the LED is off, then check the DC reactor, fan motor, and compressor. In this scenario, LED is on, so we need to check communication voltage. Open IDU cover and first check for any loose connections. If connections are proper, then check AC voltage between phase and neutral. It should be between 220 to 240 volts. Now check the voltage between neutral and signal. In healthy condition, AC and DC voltage fluctuates. In case of any issue, it shows constant voltage. If we get constant voltage, then we need to check the IDU PCB. To do that, remove cables and check voltages between phase and neutral and signal. In healthy condition, the IDU PCB will show a value between 220 to 240 AC volts, same as input supply to unit between phase and neutral. Between neutral and signal, it will show a constant AC voltage between 0 to 12 volts and a constant DC voltage between 0 to 24 volts. If the voltage between neutral and signal is not constant, it means there is an issue with the IDU PCB and it needs to be replaced. Sometimes the cable connecting the IDU and ODU could lead to a communication error. Here are a few points to check the IDU and ODU connecting cable. Cable should be made of 4 cores. Any one of the wires is not connected, it will lead to a communication error. So check if all wires are connected properly. Cable should be joint free. It should be straight and there should not be any woundings. The cable should be away from high voltage cable, that is, 3-phase supply. In case it is unavoidable to pass the power cable nearby, then there should be 1 foot distance between them. Length of the cable should not be more than 20 meters. Now let's look at the other possibilities. If the ODU drive LED is off, check the DC reactor, fan motor and compressor. DC reactor. First check for loose connection. Then check the resistance of the DC reactor. It should be between 0.1 to 5 ohms. If it is not within the range, replace it and check if the unit still shows communication error. If the DC reactor is fine, remove all other connections from the PCB and check if LED is getting on. If the LED is on, then check if the IDU shows some other error. If yes, then check for faulty component like compressor, fan motor or sensors. If the communication error remains, then check IDU PCB and voltage. We have already checked that IDU PCB is working fine, so we can conclude that ODU PCB is faulty and has to be replaced. If the LED is off, we can conclude that ODU PCB is faulty and needs to be replaced. At the same time, check the reason behind the fault in the PCB. To check that, let's check the sensor, fan motor and compressor. First check if sensor has any joints. If yes, replace such sensors with new sensors. Now check the fan motor. Depending on the model, the unit has either DC motor or AC motor. In case of DC motor, use the BLDC kit to check the motor. Connect the motor to the BLDC kit and rotate the regulator. If the motor is in a healthy condition, it rotates on moving the regulator. At standstill, if we rotate the motor shaft manually, LED blinks on the BLDC kit. If the motor is faulty, then it will neither rotate on rotating the regulator on the kit, nor the LED on the kit blinks on rotating the motor shaft manually. In such a scenario, we can conclude that the motor is faulty and has to be replaced. If the system has an AC motor, then remove the motor connector from the ODU PCB and check its resistance across 3 terminals. If the highest resistance is the sum of the 2 lowest resistances, then you can conclude the AC motor is in healthy condition. Otherwise, it is faulty and has to be replaced. Now it's time to check the compressor. Remove all the compressor connections and check the resistance across the 3 terminals. In a healthy condition, resistance between VW, WU and UV will be the same. Now check if the compressor is grounded by checking resistance between each compressor terminal and body. If the resistance shows OL, then it is healthy, else it is concluded that the compressor is faulty and has to be replaced. Please note, if the compressor is faulty, replacing new ODU drive may get damaged, causing communication error. Checking compressor and fan motor is a precautionary step when the ODU drive LED does not glow, even after disconnecting all the components from it. We have successfully identified the causes behind the error and rectified it. Thank you for watching the video. Keep learning.